Hello class, welcome back to Statistics and Mathematics YouTube channel. In our last video, we learned something about multinomial distribution. At least we were able to get some small brief introduction on multinomial distributions. We were able to date something on the PMF for multinomial distribution, mean and variance for multinomial distribution. So today, we are going to walk through some examples on multinomial distribution so that we can apply these formulas on these examples, right? So example 1 is saying, in a large city, 50% of people choose movie, 30% choose what dinner and play, and 20% choose what shopping as luxury activity, right? Luxury activity. If a sample of 5 people is randomly selected, find the probability that 3 are planning to go to movie, 1 to play, and then 1 to shopping with more, right? So once you read this question nicely, you see that there are 3 probabilities inside, right, as it's stated clearly, right? So here we are having first probability to 50%. So here will give us P1, right? Here will give us P1, and we are having 30% to be our P2, and then here will be for our P1 3, right? And we could see that a sample of 5 people were selected at random. So here will be what our N, and then they are saying that find the probability that 3 are planning, right? So here will give us our X1, 3 are planning to go to a movie, S2, 1 is planning to go to play, S3, 1 is planning to go to a shopping mall. So once we have this preambles, let's kindly visit what our worksheet. Once you come here, you will see that the preambles are being stated clearly, right? So we have P1 to be 0.05, 0.5, P2 to be 0.3, P3 to be 0.2, right? And our X1 was given as 3, X2 was given as 1, and S3 was given as 1, right? Here, this is our PMF, right? So n factorial divided by x1 factorial times s2 factorial times s3 factorial times p1 raised to the power x1 times p2 raised to the power s3 times p3 raised to the power s3, right? So at the end of the day, I think here is supposed to be 2, right? They're supposed to be 2, right? So there's the PMF we have. So what you do is just substitute whatever you see at the PMF and just substitute this number there, right? So we have our n. So here will be n factorial. We have s1 was 3 factorial, 3, so it will be 3 factorial. S2 was 1, S3 was 1. So we see 1 times 1 factorial times 1 factorial times our p. So P1 was 0.05 raised to the power x1. So 0.05 raised to the power 3 times 0.2, 0.3 raised to the power s2, that was 1, times 0.2 raised to the power s3, that was what, 1. Once you have this one and then punch it on the calculator, you are surely going to get 0.15. I think I've run it, right? That's the reason why I get 0.15, right? So that's what our first question, right? So let's go and then tackle our second question. So this is our second question, right? So for our second question, it said, in a music store, a manager found that the probability that a person buys 0, 1, or 2 or more CDs are 0.3, 0.6, and 0.1 respectively. If 6 customers enter the store, find the probability that 1 couldn't buy CDs, 1 will buy CDs, and 2 will buy 2 or more CDs, right? You see that here we are having 3 probabilities, right? P1, P2, and what? P3, right? So this is telling you that we are having more than 2 outcomes, right? So since you are having more than 2 outcomes, we cannot use binomial distribution to solve, right? If say we are having only 1 outcome here to be what? P1, right? Then we can find our Q to get what? Our Q, that's 1 minus P, right? Then we can use binomial to solve, but here we are having 3 probabilities. We have to use what? Multinomial distribution to solve, right? And here we have our n here. N people are selected at what? Random, right? As you can see, it said find the probability that 1 couldn't buy any CDs. 3 will buy what? 1 CD, and then 1 CD, and then 2 will also buy 2 or more CDs, right? So here our x1 will be equal to 1, right? Our x1 will be equal to 1, and then s2 will be equal to what? 3, and then our s3 will be equal to 2, right? As you can see here, 2, right? So once we have this preamble, you can easily find what our probability. So let's go to our worksheet so that we will solve that one day. So as I was saying, you see our P1, P2, P3, and S1, S2, and S3 are given here. So once you write your PMF, right, it's very simple for us to even get our final answer, because our N was given as 6, our X1 was given as 1, our S2 was given as 3, our S3 was given as 2. So I just write them here times our probabilities: 0.3 raised to the power x1, which is 1, 0.6 raised to the power s2, which is 3, 0.1 raised to the power 2. Right? So once you point this thing inside the calculator, go to get 0.03888. Right? So this will be what the final answer. You see, this is quite very simple, right? And then let's go through this example. Right? It said a box contains 4 white balls, 3 red balls, and then 3 blue balls. Right? A ball is selected at random and its color is written down, and it is replaced each time. Find the probability that if 5 balls are selected, 2 are white, 2 are red, and 1 is what? Blue. Right? So at the end of the day, you could see that this one, the probabilities was not given to us. Right? The probability was not given to us. We are to find the probability ourselves before we can solve these questions. Right? So you could see that our white was given as 4, our red was given as 3, and then our blue was given as 3. So if you want the total of the balls in the box, you have to add the white, the red, and the blue, as I have done here. So 4 plus 3 plus 3, 4 plus 3 plus 3, right? Surely you are going to get 10, right? As you can see here, you are surely going to get 10, right? So if you want the probability for the white ball, that one will represent P1, right? That one will be the number of white ball inside the box all over the total of observation, or the total number of balls inside the box, right? So P1 will be given as 4 divided by 10, right? And then P2 will be for the red, probability for the red ball. So it will be the number of red balls inside the box divided by the total number of balls inside the box. So here will be equal to 3 divided by 10, right? And then P3 will be n blue divided by n, right? Which will also give us 3 divided by 10, right? So at the end of the day, this will be what our probabilities. Then let's find our x, right? Our x was given as 2 for what? White, 2 for red, and 1 for blue. 1. So x1 will be equal to 2, s2 will be equal to 2, s3 will be equal to what? 1, right? And our n, you will see that 5 people were selected at what? Random, right? 5 people were selected at what? Random. Right? So I think I made some mistake here. Supposed to be 5, right? Supposed to be 5, right? Supposed to be 5. So n is equal to 5 here. Sorry, n is equal to 5, right? As you can see here, n is equal to 5. So the only part that will change here is what? The 5, right? And the 5, as you can see, so here will be 5 factorial, right? I think when I was writing, I made a small mistake, but that will not affect the answer, right? So at the end of the day, we'll get our 5 here, right? So this will be our PMF, right? This will be what? Our PMF, right? So wherever you see the P, the X, and the N, you just substitute, as you can see here, and our final answer will be given as 81 divided by 625, right? That's what our final answer. So take your time and then go through the videos again. I think everything is very simple here for you to be able to understand, right? So thank you for watching and visiting my channel. In our next video, we are going to treat something called Poisson distributions. So make sure you watch that video too and be blessed. Thank you. Bye. If you haven't subscribed, kindly subscribe. Bye.